Hello and welcome everyone. We are excited to have you join us today for what's said to be an insightful session. It's a pleasure to bring you this webinar, and we are glad to feature Tutul, one of our finest engineers. He's been on the team for an extended period of time. Also, we encourage your interaction. So if you have any questions, don't hold back, drop them in the Zoom chat anytime, and we will address them during the QA segment. Let's jump right in. I am passing it over to Tutul, who will get us started. Hi, Tutul.
Hi, hello everyone. I am Tutuldor, software engineer from AppsCode, working in the KubeDB team. Today I will be talking about Weaviate, a vector database, and how KubeDB makes deploying and managing Weaviate on Kubernetes simple, secure, and production ready. Here is quick overview of what we will cover today. First, I will briefly introduce what Weaviate is and why it is useful. Then we will look at some of its key features. After that, I will show how we can provision Weaviate easily using KubeDB on Kubernetes. Then we will follow this with a short live demo. And finally, we will wrap up with QA session. Weaviate is built for fast vector search, so it can find data by meaning, not just exact keywords. And it runs in a distributed way, which means it can scale easily and stay available even if some nodes fail. Weebit uses graph-based and flexible schema, so you can connect data and change your data model as your needs grow. And it is optimized for row latency, so search stay fast even with millions of vectors. Weebit also support hybrid search, where you can combine semantic search with filters like keyword or metadata. It works well with popular embedding models, making it easy to plug into AI and ML pipelines. And you can apply advanced filters while still keeping semantic understanding. And finally, we will support multiple data types like text, images, and structured data. Here are some use cases. Weebit can be used for semantic search, where you search by meaning instead of exact keywords. And it is also useful for recommendation system, like suggesting products, articles, or videos based on user behavior. Weebit is commonly used in RAG system, where AI models retrieve real data before generating answers. Because it supports connected data, it can be used to build and explore knowledge graphs. And finally, it can support AI agent and autonomous system by helping them understand and use data effectively. What KubeDB offers for Weebit? With KubeDB, provisioning Weebit becomes very simple. Instead of manually managing manifest, you can deploy a production-ready Weebit cluster using a custom resource. KubeDB continuously monitors the health of Weaviate. The health check are customizable, which helps detect failures early and maintain stability. KubeDB allows you to apply custom Weaviate configuration easily, so you can adjust DB behavior based on your application needs. And authentication credentials are managed securely using Kubernetes secret, keeping sensitive data out of configuration files. And KubeDB support for production-ready Weaviate version like 1.33.1. And KubeDB offers flexible deletion policies, so you can control whether data is retained or removed when Weaviate resource is deleted. And finally, KubeDB integrate with Kubernetes persistent volumes, ensuring that your Weaviate data remains safe even if pods restart or move. This diagram shows the Weaviate operator on Kubernetes, starting from the user applied Weaviate custom resource at the top. KubeDB watches this custom resource and takes responsibility for everything else. Based on the Weaviate custom resource, KubeDB automatically provisions all the required Kubernetes components like pet set, service, secret, persistent volumes, PDB, and app binding. Together, these components run in a fully functional and production-ready Weaviate cluster. At the bottom, you can see deletion policies, and this control what happens when the Weaviate resource is deleted. If the deletion policy is wipe out, then deletes everything for complete cleanup. And if the deletion policy is halt, then preserve both secrets and persistent volumes. And if the deletion policy is delete, then keeps secret but deletes persistent volumes. And the last one, if the deletion policy is do not terminate, then blocks deletion entirely to protect production data. So here is our live demo. In the live demo, I will create a Weaviate custom resource on Kubernetes using KubeDB. Here is the installation process. To install KubeDB on your Kubernetes cluster, you can use the following Helm command. You need license to install it. You can visit kubedb.com to get the license. Here you can see the sample YAML of the Weaviate. In the live demo session, I will use this YAML. The API version kubedb.com/v1 alpha 1 alpha 2 specifies the kubedb API version we are using, and kind Weaviate indicate this is Weaviate resources. And here metadata section name Weaviate sample gives the instance a unique name, and namespace demo places it in the demo namespace. In the aspect section, we see version 1.33.1 points to the specific Weaviate Docker image version from the KubeDB catalog. And replica set is 3, set up a cluster with 3 nodes for high availability and fault tolerance. Here we also see storage is access mode is read write once, ensures only one port can write to the volume at a time, and resource request storage 10 GB, allocate 10 GB of space. The port template customize the Weaviate ports, and sorry, here we have keep deletion policy wipeout. As we discussed previously, this means deleting the Weaviate resource will also remove all the associated data and resources. And health checker with period seconds 10, timeout seconds 10, and failure threshold 3 set up periodic check to ensure database is healthy. Now I am going to deploy a Weaviate instance using a Kubernetes custom resource defined in a YAML files. Once I apply this manifest, the operator takes over and start creating replicas one by one. Behind the scene, the operator ensures that each pod joins the cluster correctly and the health check pass. We can see there Weaviate pods running, which means the cluster is up and healthy with no restarts, and the Weaviate custom resource is in ready state, showing that KubeDB has successfully deployed. And here we can see that there are two secret created. One is authentication secret, and another one is custom configuration secret. And also there are two service created. One is primary service, and another one is governing service. And here each Weaviate pods has its own persistent volumes, ensuring that data is safely stored even pods is restarted. This show how KubeDB automatically provisions and manage all required Kubernetes resources for a production-ready Weaviate cluster. First, we need to port forward the Weaviate service to access its API locally. Let's port forward it. By default, the operator automatically create API key for Weaviate and store this securely inside the Kubernetes secrets, where here we can see authentication secret. We can find our API key here, and let's retrieve that secret now and decode it. Here we can find our API key. For the rest of of this demo, I will be using this API key. So let's see the Weaviate cluster nodes and their health. For that, I have to give the API key here. All three Weaviate nodes are running the same version and are in the healthy state, which confirms the cluster working correctly. Next, I will create a class. Here also we have to use API key. This command creates a schema in Weaviate by defining a class and its properties. Now the class is created and distributed across the cluster. Now we insert an object in the class. We have to use API key also. Here we insert a new object into verification class using the API. After successful insertion, Weaviate returns a ID for this object. This ID is important because we can use it later to retrieve or update this exact object from the class. So now we retrieve the object from the verification class using its unique ID. Here we have to give API key. And also we have to give here object ID. Here you can find this ID. So we can get the object here name cluster test. We can also retrieve all classes defined in Weaviate using this command. I provide this command here. Here we have to use API key also. Looks we can get classes verification class. Now see the configuration secret by decoding it. We decode this configuration secret. And decoding the configuration part. We see here the default configuration part where authorization settings up and also query defaults limit 100. Now let's create a custom Weaviate configuration secret. We create this custom Weaviate configuration secret, and in this secret we define the authentication settings, authorization settings, also query default limit updated to 400. Let's deploy it. We can see our custom config comes here. So now we redeploy the Weaviate custom resource, add in configuration section and specifying secret name Weaviate custom config to use the custom configuration we created earlier. Let's deploy it. Now again we decode our secret configuration secret. We can see our configuration updated. This authentication part comes, authorization comes, and also our query limit updated to 400. Now we can overwrite or update the custom configuration using the inline section. Like if we want to change our query defaults 400 to 1000, we can do this using our share easily. So let's deploy this one and let's see. We deploy our custom resource. And then decode this part. We can see here our query defaults change and becomes 1000. So some exciting upcoming features include built-in monitoring using Prometheus and Grafana, backup and restore, advanced off requests like scaling and upgrades, support for Weaviate, newer Weaviate versions. So that's all from my side. If you have any question about this webinar, you can ask me.
So from our audiences, do you have any questions specific to Weaviate or maybe vector database? If you have, you can ask it. So I guess there is no question at this point. With that, we conclude our today's webinar. Thank you, Tutul, for delivering an insightful session, complete with a clear and practical hands-on demo. It was a highly engaging discussion on one of the most widely adopted vector DBs, Weaviate. As we continue this series, we'll be hosting additional sessions focused on other leading vector databases as well. So stay tuned and keep an open eye for our upcoming schedule. Finally, a big thank to all of you who joined us today and actively contributed to the session. Your participation truly made it worthwhile. So until next time, take care and have a great day. Bye-bye. Okay. Live of